All right, good morning. Happy April Fool's Day. We're going to get back to exponential functions today. We'll review tomorrow for a quiz on Friday. So we'll have a quiz over exponential functions. Can you identify an exponential function by its graph? Can you identify it by its table? And then we'll also have exponential growth and decay, which is what we're doing today. So there are two types of exponential functions. And again, that's where I've got an x in the exponent. So like here, y equals 3 times 9 to the x power. It's because I've got something to the x power that I call that exponential. Or here I've got 0.25 to the x power, or y equals 9 to the x power minus 4. As long as the main part of that function there is showing up, that some number to the x power, as long as that's where my x is in the exponent, then I know that I have an exponential function. So, again, I said there are two types of exponential functions. It's either going to be exponential growth or exponential decay. And this is kind of nice because it really is what it sounds like. In an exponential growth function, the numbers keep getting bigger and bigger. They keep growing. And the base of that exponent is going to be bigger than 1. So this might be, y equals 2 to the x, or y equals 1.1 to the x, or really any number that's going to be bigger than 1. Whereas in an exponential decay function, I'm not getting bigger. My numbers are getting smaller and smaller every single time. So what's happening here is I'm getting smaller numbers because the base of my exponent, base of the power, is going to be smaller than 1. So this could be y equals 0.99 to the x, or y equals 0.2 to the x. As long as the base here is smaller than 1, I've got an exponential decay function. So we'll keep an eye out for those. And we're going to look at the two exponential functions on the bottom of this page. I've got exponential growth, exponential decay. So if I take y equals 5 to the x, well, this is just like saying y equals 5 over 1 to the x. Now if I take 5 over 1, let me zoom in here. If I take 5 over 1 to the negative second power, well, what do I do with negative exponents? Well, that makes me flip that fraction. So I'm taking 1 over 5 to the second power to get rid of that negative exponent. And 5 to the second, or 5 squared, is just 5 times 5, which is 25. And we can do the same thing here, 5 over 1 to the negative first. Well, what does that negative exponent force me to do? Well, it forces me to flip that fraction. So 1 over 5 to the first, which is just 1 over 5. I'll create, a bit more separation between these two. So I'd like you guys to fill out the rest of this table. So if you could pause the video really quickly, fill out the rest of this table. And you're just plugging in these numbers in the exponent. So, 5 to the 0 power, which is just 1. And you can use a calculator, of course. 5 to the first is 5. 5 to the second just means 5 times 5, which gets me 25. And then 5 to the third is 5 times 5 times 5, which is 125. And what we're going to really focus in on is we're not going to even worry so much about the left side of this table. What we're going to look at is, as I go from left to right, as I go from negative to positive x values, what I'm really honing in on here is what's happening to these y values. How are these changing? And if it's exponential growth, then we see that these numbers are getting bigger. They're growing. So exponential growth, these numbers keep getting bigger as I go down the y column. And that kind of reflects itself in the graph as well. As I go from left to right, I keep getting bigger and bigger numbers. This function is growing from left to right. And now let's look back at exponential decay. And you could, of course, use a calculator to fill out this table. So don't feel like you're restricted in that sense. Definitely use a calculator if you need to. You could type in 0.25 to the negative second power, which should get you 16. So again, you could say 0.25 to the negative second power in your calculator. This would be 0.25 to the negative first power, which would be 4. And the reason why that's 4 is because this decimal, what's 25 cents? What coin is 25 cents? Well, it's 1/4 or 1/4 of a dollar. And then that negative exponent makes me flip the fraction to get 4 or 4/1. So I'd like you to pause the video, use a calculator if you need to, and fill out the rest of this table. So we got 1/4 or 0.25, 1/16, 1/64. And of course, if you want to do decimals for these, that's just fine. I'm going to fill those in really quickly here. So if you want to do 0.25 and 0.0625 and 0.015625, then that's just fine. And if you want to round that to just 0.0156 or even 0.016, that's just as well. I wouldn't take any points off for that. But we're going to focus on this column here, the y column. And we're going to see how are these numbers changing as I go down the column. Well, I go from 16 to 4 to 1 to 1/4 to 1/16. I'm not subtracting the same thing every time. Here I'd subtract 12 and then 3 and then 3/4. So it's not linear. I'm not adding or subtracting the same thing every time. but I'm definitely getting smaller. So this is an exponential function, but it's getting smaller. It's decaying. And if we look at the graph from left to right, this thing is getting smaller. So always look at the graphs from left to right, just like you read, and always look at the y columns from top to bottom. All right, so let's look at this next page. Again, take a quick peek at this sort of form of the growth and decay graphs. And we're going to get some practice identifying those graphs here. So we're going to identify if the graphs are exponential growth or decay. So left to right, what is it doing? Is it getting bigger? Is it growing? Or is it getting smaller? So I'd like you to pause the video and try to identify or classify these first 6. All right, left to right, getting smaller, so decay. Same thing here, left to right, getting smaller, decay. But what's happening here? From left to right, I'm getting bigger and bigger and bigger numbers, which must mean that's growth. Here we're back to left to right, smaller and smaller numbers. All right, what's happening here? Left to right, I keep getting bigger and bigger numbers. So left to right, I'm going up and up. And left to right, keep going up, 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 up from left to right. So that's exponential growth. All right. And again, this is sort of a review from yesterday. We're checking out if these tables are adding the same thing every time. Is that a linear function? Or is there multiplication going on? Is this an exponential function? So let's look at number 1 and 2 together, and then I'll leave you guys the last 4 to try. So what's the difference here? Well, I'm 6 to 12, I could add 6. But is that still adding 6 for my next one there? Well, no, I've got to add 12. So that pattern didn't work. Well, let's see. It's not linear. Let's see what pattern we could find. So not linear. Let's try to find this pattern. So we said it's not adding 6, but I could multiply by 2. And let's see if that pattern still holds. 12 times 2, is that 24? Yep, so that seems to work. And 24 times 2 is 48, so that one is exponential. And number 2 here, again, we're really just focusing on that right column, that y column. So 50 to 10, I could either divide by 5 or subtract 40. Let's try dividing by 5 or multiplying by 1/5. So I could divide by 5. 50 divided by 5 is 10. Let's see if that pattern holds. 10 divided by 5 is 2, so that seems to work. And let's just go one more to make sure. 2 divided by 5. If I type in 2 divided by 5 in my calculator, would I get 0.4? Well, let's just make sure. Always better to be safe than sorry. Yep, 2 divided by 5 is 0.4. So this works out. It is a consistent pattern, but since I'm not adding the same thing every time, it won't be linear. It will be exponential. So why don't you guys pause the video here, try these last 4, and then check back in in a second. Okay. So let's see here. I've got, 35 and 29? I could subtract 6. And does that still work? 29 minus 6 does get me 23 minus 6. Yep, that gets me 17. So since I'm adding or subtracting the same thing every time, it's not going to be exponential. It must be linear because I'm adding or subtracting. All right, let's try number 4 here. So again, really not worried about that left column too much. 32 to 28. I could subtract 4. Does that pattern still hold? 28 to 24. That still seems to work. And 24 to 20. All right, that is great news. Our pattern worked for every single one of these. So if I'm subtracting or adding the same thing every time, it'll be a linear function, which means it's definitely not exponential. And our last two here. What's going on in 5? It's from -2 to 0. I could either multiply by 0 or I could add 2. So let's try, multiply by 0. And 0 times 0. Well, that wouldn't get me 2, so that can't work. Let's try another pattern. What else could that be? How else could I go from -2 to 0? Well, I could add 2. And if I add 2 again, then I would get to 2. And if I add 2 again, then that worked one more time. I did get 4. So I'm adding the same thing every time, which makes that a linear function. And our last one here, 17, 51. I could add 34 rather, but I can tell pretty quickly that that's not going to keep working, that adding 34. So how else can I go from 17 to 51? Well, if you're not sure, you can always try dividing the two numbers and see if you get a nice whole number out of it. So 51 over 17 gets me 3. So what that says is if I multiply 17 by 3, if I take 17 times 3, I should get 51 times 3, and you can check in a calculator. 51 times 3 is 153. And our very last one here, 153 times 3, does end up getting me 459. So here, if I'm multiplying by the same thing, then I've got an exponential function. And our very last question for the day, before you take your Google form quiz, the very last question here is I want us to go back and look at these exponential functions. And we're just going to see if these are growth or decay. So are the numbers in the right column getting bigger and bigger, or are they getting smaller and smaller? So we don't need to worry about the linear ones. We're just going to focus on the exponential. So number 1 is exponential. And are these numbers, as I go down the list, are they getting bigger or smaller? Well, I keep getting bigger. I keep doubling in size. So I would say that's an exponential growth function. And the graph would look something like, that. And number 2 is another exponential. And as I go down the list, what's happening to my numbers? as I go down that list, those numbers keep getting smaller. I keep dividing by 5. So I'll call that an exponential decay function. And why don't you guys look at number 6, try that last one for me, and that'll be the last thing we do. So as I go down the list, what's going on? Am I growing or decaying? Well, I keep getting bigger numbers, so that would be exponential growth. So keep an eye out there for that Google quiz or Google form quiz on the classroom page. That's, again,